In this question, we will again do the analysis of discrete time LT system. So, in this question is given, consider a discrete time LT system with impulse response h of n is given by 1 by 2 raised to n into u of n. So, impulse response of the system is given, and use Fourier Transform to determine the response of the signal. Means we need to find out the response of the system, okay, and the input signal is given x of n. I will give you the exact meaning of the question, and here this is the system, discrete time LTA system, and the impulse response is given. So this is the impulse response which is given by 1 by 2 raised to n into u of n, and input signal is also given, x of n is equal to 3 by 4 all raised to n into u of n, and we need to find out the response of the system, that is y of n we need to calculate. And if it is a discrete time LT system, y of n of a system can be written as x of n convolution h of n. So that's a time domain equation which can be written as k is equal to minus infinity to infinity x of k into h of n minus k. If you evaluate this equation, you can find out y of n, but in the question is specifically mentioned that use a Fourier transform to determine the response. So instead of using y of n is equal to x of n convolution h of n, we need to use DTFT to calculate the system response. So here we can use the transform concept, that is if there is a convolution in time domain, by using DTFT properties becomes multiplication. So if you use this property here, you can write the transform of this equation, means the DTFT of this equation, DTFT of this equation, I can write DTFT. So I can write y of e raised to j omega is equal to x of e raised to j omega into h of e raised to j omega. So by using convolution property, I can write y of e raised to j omega is equal to x of e raised to j omega into h of e raised to j omega. Means I need to take the DTFT of x of n and h of n. So I can write x of e raised to j omega. Here x of e raised to j omega can be written as the transform of 3 by 4 all raised to n into u of n. So by using the basic formula, I can write it becomes 1 by 1 minus 3 by 4 e raised to minus j omega. So I got x of e raised to j omega. Now h of e raised to j omega. H of e raised to j omega is equal to 1 by 1 minus 1 by 2 e raised to minus j omega. So I got the two equations, the transform of h of n and x of n. Now I can substitute here. So y of e raised to j omega can be written as 1 by 1 minus 3 by 4 into e raised to minus j omega into 1 by 1 minus 1 by 2 e raised to minus j omega. So now we got two factors, and when there is a second order equation, always do in a positive factors. So here it is minus j omega, I need to make it plus e raised to j omega, so I can multiply the numerator and denominator by e raised to j omega. Similarly, to make this term positive, e raised to j omega, I need to multiply numerator and denominator again by e raised to j omega. So I can write the equation y of e raised to j omega is equal to make the first term positive, I will write e raised to j omega numerator, and I can also write in the denominator. So e raised to j omega minus 3 by 4. So I got one term, and the other term again I need to multiply with e raised to j omega, the numerator, and the denominator also. So e raised to j omega minus 1 by 2. So I got two terms. Now I need to write 1 e raised to j omega to the left side. So if I modify this equation, y of e raised to j omega divided by e raised to j omega. When you do the second order equation, or in order to find out the inverse of the signal, I always write in this form, the transform divided by e raised to j omega. So remaining I will get e raised to j omega divided by e raised to j omega minus 3 by 4 into e raised to j omega minus 1 by 2. Now I need to perform the partial fraction, so that I can write a by e raised to j omega minus 3 by 4 plus b by e raised to j omega minus 1 by 2. So now I need to make this LHS and RHS equal, so I need to take the LCM. So I can again rearrange this, so it becomes a into e raised to j omega minus 1 by 2 plus b into e raised to j omega minus 3 by 4, and the denominator is equal to e raised to j omega minus 3 by 4 into e raised to j omega minus 1 by 2. So now from this I can understand that the LHS of the equation, that is this term, which is equal to the numerator of this equation RHS, and denominator also same. So I can equate these two terms, e raised to j omega. So if I equate this, e raised to j omega can be written as a plus b into e raised to j omega and the remaining term minus a by 2 minus 3 by 4 b. So I got equation. Now I can compare the coefficients of these two equations. E raised to j omega coefficient is 1, so a plus b is equal to 1. I can write, so a plus b is equal to 1, and another equation I can write minus a by 2 minus 3 by 4 b, which is equal to 0, because the coefficient of constant term is, or constant time is 0, so I can equate this constant time is equal to 0. Now if you solve these two equations, I can write a is equal to, after simplifying these two equations, I can write a is equal to 3 and b is equal to minus 2. So I got two equations. Now I need to substitute here, I need to substitute in this equation. Okay, so I'll rewrite this equation next page. So I can write y of e raised to j omega by e raised to j omega is equal to, I can write a becomes 3, so I can write 3 by e raised to j omega minus 3 by 4 plus minus 2 divided by e raised to j omega minus 1 by 2. So I simply substitute a and b. Now I can cross multiply this e raised to j omega to the right side. So the y of e raised to j omega, now we can write y of e raised to j omega is equal to 3 e raised to j omega divided by e raised to j omega minus 3 by 4. This is one term. Another term is minus 2 by 2 into e raised to j omega divided by e raised to j omega minus 1 by 2. Now I need to write take e raised to j omega common in the numerator and denominator, so the final expression will be like this: 3 by 1 minus 3 by 4 e raised to minus j omega minus 2 into 1 by 1 minus 1 by 2 e raised to minus j omega. From the standard equation, you know that a raised to n into u of n, the DTFT can be written as 1 by 1 minus a e raised to minus j omega. So based on this, I can find the inverse. So here it is y of e raised to j omega. Now I need the response or the output of the system y of n, means I need to take the inverse DTFT of the signal y of e raised to j omega, means I need to take the inverse of this equation. So it becomes 3 into 3 by 4 the whole raised to n into u of n minus 2 into 1 by 2 the whole raised to n into u of n. So now we got the output of the system. So in the question it is given that the response of the system we need to find out, means the output we need to calculate. So we need to find out the response. So finally we got the output y of n.